Hello everyone and Happy New Year! So, in last episode we finished up the basic structure of this elevator and now it's time for everything else. Alright, as I said in last episode, there are basically 3 more things that we need to figure out and build before this elevator is operational, which is the counterweight, gearbox and the electronics. I think we should start with the counterweight because this thing is so heavy. I can barely do it myself. And it's gonna be even worse when you get the Mitersaw on top of this. So, we gotta figure out that counterweight. I went looking around in the barn to find something I could use as the counterweight. It had to be something I could actually adjust, so I could get the elevator perfectly in balance. My idea was to use some sort of bucket, can, or something I could fill sand or dirt to fine-tune the weight with. So I started digging through all the random stuff laying around in the barn. All tools, rusty parts, empty containers, and eventually I found it. A 25-liter can that looked like it could handle a lot of weight. I carried it outside and started filling it with sand. And yeah, that took a while. A lot of shoveling. When it was finally filled all the way to the top, I measured the weight to roughly 46 kilograms or about 101 pounds. Definitely gonna be heavy enough. Now came the fun part, getting this thing up the ladder to where the counterweight is supposed to be mounted. And let's just say, it was not easy. Between a small ladder, hatch and a lot of weight, it turned into a bit of a workout. But after some struggling, a few breaks and a lot of careful lifting, I finally got it up there. Before I could actually hang up the counterweight, I still had a few things to take care of. I had to mount the attachment points, hang up the rope, and make sure the elevator itself was properly secured, because everything had to be in the right position, otherwise the rope wouldn't be attached at the right point. Once the elevator was locked in place and everything was lined up, I could finally attach the weight, and just like that, the counterweight was in position and ready to do its job. Alright, everything should be fine for testing some of it. So I have filled up the counterweight with sand and secured the rope, so everything should be ready. So when I take out this screw, nothing should happen. Or what could happen is the elevator starts going down. But I think the counterweight is heavier than the elevator, so I think nothing should happen. After attaching the counterweight, the elevator suddenly became really easy to push into the roof. It almost felt effortless. But there was one big problem. I could only push the elevator in one direction. Pulling it back down? Yeah, that was a different story. It was way too heavy to move. So at that point, I started to suspect that the counterweight was simply too heavy for the elevator, especially since I hadn't even checked the actual weight of the elevator yet. Just as a quick test, I added a Mitersaw to the elevator as well, to see if that would help balance things out and make it easier to pull down. It didn't, not even close. So the next step was obvious. I had to properly balance the whole system. I measured the weight of the elevator and it came out to about 32 kilograms. Then I compared that to the counterweight, which is 46 kilograms. And yeah, that was a pretty big difference. It was no wonder it didn't want to come back down. So I grabbed the can again and started removing some of the sand, little by little, until the counterweight was down to around 36 kilograms, which is much closer to the elevator's weight and way more balanced than before. So, when it comes to the gearbox, we gotta find a new solution, because the windshield wiper motor we used in the last episode didn't really work, or it did work but it wasn't strong enough, so we need a new solution. So this is what I've come up with. I have this old washing machine motor laying around, which is most likely going to be powerful enough. The problem is, first off, it's going to be running on 230 volts. I was planning on running this elevator on 12 volts, but it shouldn't be a problem. And the other thing, this motor runs on 1500 RPMs, which should be just too fast for this elevator. Like, you wouldn't want the elevator to go bang and then go down, it's gonna ruin itself, and we don't want that. So this is where the gearbox come in. This one, it's almost finished. So here's the deal. This gearbox contains 4 modules, and each module is 1 to 3 in gear ratios. So if my math is right and my understanding of gearboxes are correct, this gearbox should be 1 to 81, which would give us 1500 RPM in input and roughly 18.51 RPM in output, which I think would be good enough speed for the elevator. If not, I gotta change the gear ratios because I can't change the speed on the actual motor itself. So let's just catch up where I left off and finish up this gearbox and see if it actually works and if we can use it. Alright, the gearbox is now finished, and for the first test I'm just going to plug it in and see what's going to happen. And from the looks of it, it seems to be working as it should. And I'm concerned it's going to make a lot of noise, but only one way to find out. Oh wow, that's loud. Okay, it's working great. I think I gotta find a solution for the noise problem because it's so much noise. There's a little bit plastic at the bottom of the gears, so I think the lifespan of these gears are quite limited. The good side is that these gears are not going to be spinning that often, like only when the elevator is going up and down. So should be fine. The good news, the gearbox is working exactly as I expected it to be. The pulley is really strong and I think we shouldn't have a problem to pull the elevator. So there's only that noise problem. Now with the counterweight out of the way, we have the gearbox. In the original plan, I was planning to have the gearbox on the floor, but I think it would be just as good to mount the gearbox in the roof, because this is really tight and it would put a lot of pressure on the gearbox. Like, if we have the gearbox mounted on the floor, we would have the rope coming like a V shape right here, which would really try to pull it up. And if we mount the gearbox in the roof, it wouldn't really pull on it either way. So I think the best way is to just mount a gearbox in the roof. Let's get on with it. Okay, there we go. The elevator, the counterweight, and the gearbox. There has to be so much tension on this gearbox right now. It's like guitar strings, or yeah, at least there's a lot of tension here. So I can't really move the elevator much before we connect up the gearbox. So over to electronics. All right, here is the plan. So we're gonna make a PCB to control the elevator. I'm not gonna go in too much detail of how this is gonna work. So this one is basically just the input for the 230 volts. This one is the input for the 12 volts. This one is the main switch that's gonna control the elevator going up or down. This is the limit switch that's gonna be on the top of the elevator, so we know exactly when the elevator is at the top. This one is basically just the same, just on the bottom. And this is the motor contact, which has 4 outputs to make the motor go both directions. I did have a few complications with the prototype PCB, because the pin positions on the relay didn't go along with the hole positions on the PCB, so I kinda have to make my own holes, but eventually I managed to solder them on the PCB. So I don't know what I was doing last year, but if I make this schematic, which was what I was working on, the elevator wouldn't work. The reason is because of these two transistors. And the reason I have these transistors is for kind of an interlock. I don't know if that's the right word, but the purpose of these transistors are basically to make some sort of short circuit protection. And the problem with the transistors are basically the base voltage or supply. They don't get the supply when they should or at the right time, which means the transistors won't open, which also means the elevator won't start. Well, enough about that. The only thing you should know is that this won't work. And that's why I made this. This is a version 2 of the schematic, which only the slight modifications I've made is adding 2 more transistors to make the interlocking work properly. Also added 2 voltage regulators to give the base voltage of the transistors the right voltage, so they don't burn up with the intended voltage I was doing here. And I also added 2 LED indicators to indicate whenever the elevator is up or down, or going up or going down. They only turn on when the elevator is in use. And the good news is, the test circuit board I started building last year, the layout for the circuit board is still pretty much the same, or it is the same as this new drawing, because I didn't finish everything on this circuit board. Like, I didn't connect anything on the back and I didn't add the transistors. So everything we need to do is complete the circuit and put it up in the elevator, connect up everything up there, and then we'll get a first test. So let's go. Small space. Alright, almost there. We just have to connect up the elevator or all these cables to the circuit board. Yeah, before anyone points it out, this circuit board is temporary. It's not supposed to look like this when it's complete. I just made this circuit board in a hurry just to be able to see if the design is going to work, and also to see if the elevator is going to work. So just before anyone points it out, this is not permanent. Now, we're finally ready to take the first test of this elevator, but I did have to move the counterweight to this position, because on the last place we had the counterweight, it kind of was hitting the floor before the elevator got all the way up. And the problem with that is when we trigger the elevator would go all the way up and trigger the limit switch. But since the counterweight is on the floor, there is slack on the rope. So after the gearbox stops pulling, the elevator would kind of go slightly back and open limit switch, and the gearbox would start again. And that would create kind of a continuous loop, and the elevator would never be able to go all the way up. But that's sorted out. The counterweight has been moved and everything should be ready. The circuit board is all wired up. What we have to do now is plug it to the battery and the 230 volts. Yeah, here we go. Okay, here we go. Okay, something's not right. Okay, so brown. Quick fix. Okay. Ah. No. Ah.